completed my PhD studies with Dr. Tom Seeley at Cornell University, and now I'm a postdoctoral associate also at Cornell in a different department. But today I'm going to talk about my PhD work on the mite-resistant bees, or at least the survivor bees of the Arnot forest living in Ithaca, New York. Luckily, because this is a bee conference, and even more luckily because we're a good way into our sessions on Varroa and parasite resistance, I don't need to introduce very much about the cast of characters in my story here. We've got the parasitic Varroa mite, we've got Apis mellifera, and we have less than 100 years of an evolutionary relationship in which those parasites and those hosts have been negotiating just how harmful their interactions will be. So all interactions between a parasite and a host hurt the host. That's what makes the parasite a parasite. And in this case, and in all cases, what we have is this negotiation where the parasite can decide just how hard it's going to try to exploit the host, and the host can in turn respond with any of a number of different resistance or tolerance mechanisms that will allow them to deal with whatever the parasite throws at them. And so, in my case, I have been fascinated by this idea that in this very brief time that Varroa and Apis mellifera have been interacting with one another, they have been engaged in this negotiation about how much harm will come of their interactions. And many people, as we've been talking about today, are engaged in the act of trying to breed a mite-resistant bee, or a bee that can tolerate having high Varroa infestation. And as you just brought up, many of these breeding programs have focused on finding that silver bullet strategy, that perfect mite-resistant trait that's going to take our bees from susceptible to never needing another chemical treatment again. Thus far, we haven't had that much success. We do not have that perfect mite-resistant bee, and in fact, we can't even agree on what that perfect mite-resistance trait is, what that one thing that we should certainly be selecting for is. This is a figure that you should be familiar with. What we can do is we can look to nature. We can look to what happens when honeybees are left to their own devices, or are put out into nature again and left to their own devices, and are allowed to evolve in interaction with the Varroa mite and try to solve this problem themselves. Instead of us thinking of what we think the cleverest strategy might be, we instead ask the bees what they will do in this situation. And what you will see here on this map of survivor populations of bees is that conveniently right next door to me in Ithaca, New York, is the Arnot Forest survivor population. So that's what we're going to talk about today. But in order to talk about the Arnot Forest bees, this is the Arnot Forest. It's a 1,700 hectare deciduous forest in upstate New York. It's managed as a research preserve, so there is occasional logging, but much of it is left to its own devices, just as the bees are left to their own devices. To tell you this story, I need to tell you about my advisor and collaborator on this work, Dr. Tom Seeley. So many of you are already very familiar with Professor Seeley, but Professor Seeley comes into this story late. First, we need to start talking about bee enthusiast and student Tom Seeley, who in 1978 went out into the Arnot Forest with Kirk Fisher, and they decided that they were going to map all of the trees, all of the bees living in trees in the forest. And they did so successfully. They characterized the population, they determined the density at which they were living, and they thought very fondly of those happy forest bees living on their own until 1995, when Varroa was first detected in Cornell University apiaries. And as we all know, when Varroa arrives, all of the feral bees die, and so Tom thought to those lovely forest bees and imagined that they must have been going through hell and were probably all gone. But because he's a good scientist, he decided, even though it was depressing, he was going to go out to the forest and just confirm that those feral bees were no more. And in fact, what he found was they were still there. And what he found, indeed, was that they were there at the exact same densities that he had found them in 1978. So the population didn't appear to have gone anywhere. It didn't appear to have changed as a result of Varroa arriving. So first he thought, well, surely that just means that Varroa isn't present in the forest. Maybe they're protected, no commercial beekeepers operate nearby. But we caught swarms, and those swarms have Varroa mites. So that wasn't the answer. Then some people suggested, well, perhaps in 2002, they had only just recently gotten the parasite, and that they will surely be dead a few years later as they inevitably collapse in the face of this parasitic mite. So a survey in 2011 was conducted and found that, in fact, they are still living at the same density in the forest. So these are bees that are living alone without beekeepers, entirely without us, all the help that we imagine our bees desperately need. These bees are able to survive without, even though they've got this parasite. And indeed, a genetic analysis shows us that this isn't just bees living in the same place that there used to be bees, but that maybe had escaped as swarms from a nearby operation, helped along by a beekeeper. These are, in fact, genetically the descendants of those bees that had lived in this forest in 1978. So this is a survivor population that has been living alone this entire time, and it has not meaningfully experienced any genetic introgression from other bee operations nearby. So that sent me out to answer the question, how are these bees surviving with Varroa mites? So this is me setting up one of our number of hanging bait hives that we've used in the forest. And you need to set up hanging bait hives because the forest has got a nice healthy population of bees, but it also has a nice healthy population of bears. Bears ate my homework on more than one occasion during my dissertation. But we were able to get enough colonies out of the forest that decided to move into these hanging, swinging, swaying boxes. It was much easier for me when they moved into the bait hives, but if they moved underneath and made some comb, I could still collect them and move them into length-growth hives that I could then conduct some tests on, far away from the bears in the forest. And so that's what I did. We took these bees and we evaluated them for a number of these different mite-resistant traits that we've already heard about today. So the first we looked for was hygienic behavior, and we assessed this using the freeze-killed brood assay. And what we found was that we would take liquid nitrogen, we would freeze a sample of bees, we would come back 24 and 48 hours later, and we would figure out how many of those cells had been detected by the bees and then entirely emptied and cleaned out. And so these are the data that we've collected from a population of 12 colonies. We got 24-hour measurements. 11 of them we got 48-hour measurements. That's a funny story, but I'll not go into it. But what we found was that the Arnot forest bees, about 75% of the bees are hygienic within 24 hours, or rather 75% of the frozen cells are removed within 24 hours. Within 48 hours, 96% are removed. And so that's interesting, but what it really means requires comparison to other bee populations. And so we did conduct controls at the same time. We would buy bees from queen breeders that were reputable and operating in the United States. But to no one's great surprise, those queen breeders who are aware of Varroa mites, are trying to combat Varroa mites, and are in fact aware of this freeze-killed brood hygienic test, had presumably been doing that on their bees. And so in comparison, the Arnot forest bees are not as hygienic as the bees that one might buy from a queen breeder in, say, California. However, what we find more interesting is comparison of the Arnot forest bees now to what we imagine the Arnot forest bees were doing before Varroa arrived. How hygienic were these bees before they met this parasite? And so I asked Tom if we could apply for money to build a time machine and go back and sample them, but he told me that that would be too expensive and physically impossible. So we did the next best thing. What we did was we looked through the literature and we said, well, Varroa arrived in 1995. What were other bees in North America and around the world doing at that same time? And so we actually found data. Some of this is from Marla's work, Spivak and Downey, 1998. Some of it is from Ben Oldroyd's work in Australia that he published in 1996. But both of these are unselected colonies that had not been selected for hygienic behavior, that were evaluated using the same test in 1995, when we presumed that the Varroa mites arrived in the Arnot forest. And what you see is that the Arnot forest bees, though they're a little lackluster in comparison to the currently available hygienic bees that you might buy from a queen breeder, are still very much outperforming these bees that hadn't experienced the same degree of selection. And so what that suggests to us is that the Arnot forest bees are hygienic, and they're pretty hygienic compared to many bees that they might be compared to, but they're not expressing that trait at the maximum level. The next silver bullet trait that we evaluated was grooming behavior. And for this, we based our work on Greg Hunt's work on the Purdue anglebiter stock of bees. And so in this assay, you put a sticky board underneath the colony, you collect the mites that fall underneath it, you make sure that ants and other pests can't sneak underneath and start nibbling on the legs of the mites. And then you very, very painstakingly sit at a microscope and you evaluate each and every mite. And you figure out, does it have all 8 legs? Does it have the tips of all 8 legs? Is there any evidence that this mite has been damaged by the bees? And when we evaluate the Arnot forest bees, we find that for the 8 colonies that we evaluated, about 35% of those bees, of those mites underneath the colonies are being damaged. Again, that's really only interesting in comparison to other colonies. If we compare them to bees from a commercial apiary, from a commercial queen breeder, what we find is that only 20% of those bees were grooming, 20% of those mites were being groomed by the bees. If we again compare to some more historical data, we find that the initial starting stock that gave rise to the Purdue anklebiter bees were grooming about 5% of the mites that fell down onto that bottom hole. By the end of that breeding program, and these are the data from 2015, but Greg has explained to me that they've really not gotten above 50% grooming. 50% is the maximum level that they see. So once again, the Arnot forest bees are expressing this trait. They're expressing it at a high level, probably a much higher level than they would have been expressing it when the Varroa mite arrived, but they're not expressing it at the maximum level that we know breeding can achieve. The last trait that I'll talk about today is the uncapping recapping trait, which we've also been discussing a bit. In this, you evaluate how many of the cells that contain nearly emerged bees have, over the course of their pupation, been uncapped and then recapped by the bees in the hive. And so we took samples of comb from each of the Arnot forest colonies and we evaluated them. And what we found was that of those colonies, about 50% of the infested cells that we identified had been recapped. This is in keeping with data published by Melissa Adi and Ralph Wickler and others from 2018 on a number of other survivor populations. So here you see in gray the populations of bees that are considered survivors, and then in each of those other locations, they did better science than we did and had mite-susceptible bees from the local area. And those bees obviously were performing considerably lower at this level. So again, we see that the Arnot forest bees are not the absolute maximum recappers of the world, but they're certainly performing well at this assay. So, there are other traits that exist. We know that small colony size and frequent swarming, the lifestyle of being bees living in a forest, is an important part of how these bees are able to survive. I'm not going to give away Tom's entire keynote for Thursday morning, so I encourage you to go to that, where he will be talking about these bees and others. We also have some evidence that the development time of these bees may be slightly reduced, but those data are a little equivocal, so I'm not going to bring them up now. But the important point that we observe in the Arnot forest population is that these bees are expressing multiple resistance traits. They're expressing them at levels that we think are higher than the traits that their ancestors probably expressed them, but they're expressing the traits at a much lower level than we can achieve when we breed carefully and selectively for these traits. So the question is, why? Why is it that these colonies aren't just picking the best trait, like us queen breeders like to do? And one possible answer for that is that there may be costs to expressing a maximum level of any of these traits. It may be beneficial to express a few traits at an intermediate level, instead of suffering the costs that may come about when you are excessively hygienic and rip out healthy brood, when you groom so vigorously and so intensely that you wind up being an inefficient worker because you're so enthusiastic about grooming at any chance you get. And there are opportunity costs in uncapping and recapping as well. Another thing to consider is that just like with miticide resistance, when mites evolve a resistance to some bee trait, that knocks the bees back to square one. It knocks that negotiation between parasite and host back to the beginning. If instead the bees are using a multitude of traits, any advantage that the mites might get in perhaps not being as detectable by a hygienic bee won't necessarily help them fight off the intense grooming that those bees are expressing. So those multiple traits may be adapted. So these are the conclusions. The Arnot forest bees are expressing these multiple traits, and that queen breeding, bee breeding in general for Varroa resistance needs to be careful about maintaining that silver bullet mindset and looking for the one trait that we can easily select for and produce the perfect mite-resistant bee. I'd like to acknowledge the funding sources that have made this work possible. I'd also like to acknowledge the Varroa mite, without whom none of this work would have been possible or necessary. And with that, I'll take any questions if we have time. If not, this is my email, and you're welcome to get in touch.